Finding the x-intercept in quadratic problems with Professor Lyon's Noah Goldberg. Before I begin, I would like you guys to do a do now for me. There are many different ways to find the x-intercept in quadratic problems, so I'm curious to see which way you guys choose to do. While you guys are busy doing your do now, I'd like to take this time to tell you all to come out and support your Schechter Lions athletic program, especially varsity baseball. After solving these two equations, please raise your hand and tell me what method you used to solve them. Method number 1, the quadratic formula, also known as minus b plus or minus the square root of b squared minus 4ac over 2a equals x. The discriminant, which is essentially the b squared minus 4ac that is under the radical sign in the quadratic formula, can either be equal to 0, greater than 0, or less than 0. If the discriminant is equal to 0, there is one real root. If the discriminant is greater than 0, there are two real roots. Lastly, if the discriminant is less than 0, there are no real roots. Here's an example of when the discriminant is greater than 0. You take the numbers from the equation y equals ax squared plus bx plus c, which in this case is y equals x squared plus 7x minus 8, and plug that into the quadratic formula, which is x equals minus 7 plus or minus the square root of 81 over 2. The answer of this is x equals minus 7x plus or minus 9 over 2. When you insert the plus sign for the plus or minus, the answer ends up being 1. And when you insert the minus sign for the plus or minus, the answer ends up being negative 8. Therefore, you can see that there are two real roots when the discriminant is greater than 0. Here's an example when the discriminant is equal to 0. You take the numbers in the y equals ax squared plus bx plus c form again, which in this case is y equals 2x squared plus 4x plus 2, and plug it into the quadratic formula, which is x equals minus 4 plus or minus the square root of 16 minus 16 over 2 times 2, which ends up being x equals minus 4 plus or minus 0 over 4. Whether you plug in the plus sign or the minus sign for the plus or minus, your answer both times ends up being minus 4 over 4, which is the same thing as saying negative 1. Therefore, when the discriminant is equal to 0, there is one real root every time. Here is an example when the discriminant is less than 0. You take the numbers that are plugged into the y equals ax squared plus bx plus c form, like all the other ones, which in this case is y equals 6x squared minus x plus 1. This ends up being x equals 1 plus or minus the square root of negative 23 over 12 when you plug it into the quadratic formula. And regardless of if you plug in a plus sign or negative sign for the plus or minus, each time you will end up with an imaginary number. Therefore, there are no real roots when the discriminant is less than 0. Method number 2 for finding the x-intercepts in quadratic problems, completing the square. So here you have 0 equals ax squared plus bx plus c. And if a equals 1, here's an example. X squared plus 6x plus 5 equals 0. So initially 5 is the c, however when I subtract it over, I am missing a c value for over here where this blank initially was. My new equation ends up being x squared plus 6x plus 9 equals minus 5 plus 9. I find this because if you look over here, b over 2 squared equals c, and in this case my 6 is my b, so 6 over 2 is 3, 3 squared equals 9. So my c, which I plug into here, is 9, and whatever I do on one side, I also have to do on the other side of the equal sign. Therefore, my equation ends up being x squared plus 6x plus 9 equals 4. So I know that the square of x plus 3 equals x squared plus 6x plus 9. So therefore, I can simplify that and write the equation as x plus 3 squared equals 4. And in order to get rid of this square, I square root that, and I also square root the other side of the equal sign, which is 4, and I end up having x plus 3 equals plus or minus 2. So x equals minus 3 plus or minus 2, and if you plug in plus for the plus or minus, then it equals 1, and if you plug in negative for the plus or minus, then the answer is minus 5. When a is greater than 1 and I want to complete the square, it's important for me to realize that what I need to make the coefficient equal to 1. So in order to do so in this example where 2x squared plus 6x minus 5 equals 0, I divide everything by 2, which is the coefficient of a. So 2x squared divided by 2 equals x squared, 6x divided by 2 equals 3x, minus 5 divided by 2 equals minus 5 over 2, and 0 divided by 2 equals 0. Therefore, my new equation is x squared plus 3x minus 5 over 2 equals 0. Here, just like before, I need to solve what my c value is here because I moved my initial c value onto the other side of the equal sign. In order to do so, I have to look at my 3, which is my b again, and plug it into b over 2 squared equals c. In this case, 3 is my b, so 3 divided by 2 squared equals 9 over 4, and I add that to both sides of my equal sign. Therefore, my new equation becomes x squared plus 3x plus 9 over 4 equals 19 over 4. That is the same thing as saying x plus 3 over 2 squared equals 19 over 4, and in order to get rid of the square, I square root this, and I end up having x plus 3 over 2 equals plus or minus the square root of 19 over 2. Then, if I plug in the negative for the plus or minus, I end up having minus 3 over 2 minus radical 3 over 2. Or, if I plug in the plus, then I have minus 3 over 2 plus radical 19 over 2 equals x. Both of these are ugly answers, but this is the reality. Method number 3 to finding the x-intercepts in quadratic problems. Factoring. There are 3 basic forms that I will show you how to factor. Method number 1 is y equals x squared plus bx plus c. Here, you need to find what two numbers multiplied together equal c, but added together equal b. In order to help you guys visualize this, here is an example. Y equals x squared plus 7x minus 8. So here you see that minus 1 times 8 equals minus 8, and minus 1 plus 8 equals 7. So the c and the b here match up. So x minus 1 times x plus 8 is a simplified form of x squared plus 7x minus 8. And in order to find your x-intercept, you set both of these answers equal to 0. And so you find that x equals 1 and x equals negative 8. Method number 2 to factoring is y equals ax squared plus bx plus c. Here, the a is greater than 1, so the coefficient here, for example, is 2. So y equals 2x squared plus 4x plus 2. And in order to solve this, I have to make sure that the coefficient ends up equaling 1. And in order to do so, I end up isolating the 2. So I have y equals 2 times x squared plus 2x plus 1. And now I can FOIL or factor as I did earlier in 1. So y equals 2 times x plus 1 times x plus 1. And x equals minus 1 and x equals minus 1. The last method to factoring is with perfect squares. So y equals x squared minus c squared. And in order to help you guys visualize this, I have my example here, which is y equals 4x squared minus 9. And when I simplify that or factor it, I end up having 2x minus 3 times 2x plus 3, because when you multiply these two parentheses back together and FOIL them, it ends up having the answer above. Then, in order to find your x-intercept in this quadratic equation through factoring, you set each of them equal to 0. So 2x minus 3 equals 0. That equals x equals 3 over 2. If you set the other one equal to 0, which is 2x plus 3 equals 0, you end up having x equals minus 3 over 2. The last method for solving for the x-intercepts in quadratic problems is using your calculator. So I have the TI-84 Plus, so I'll show you guys how to do it on here. First, you push y equals and you plug in your equation. So my equation here is x squared plus 6x plus 9, and I push trace to trace it onto a graph. Then I push second calc, go down to 0 to find my zeros, which are essentially my x-intercepts. Push enter. Left bound, enter. Right bound, enter. Guess, enter. And I see that my 0 ends up being x equals minus 3. This is the exact same thing as doing it any other way that I've previously showed you. And if you guys know Advantage Tutoring, they give you this very good program, which I'll show you guys how to do also. You push program, go down to factor, which is 4, push enter again, and you plug in what your ax squared plus bx plus c equals 0 form would be. So here, for x squared plus 6x plus 9, my a would equal 1, my b would equal 6, and my c would equal 9. And when I push enter, I see that it gives me the factored form, which I previously just taught you. And if you set them equal to 0, then you see that your 0 is x equals minus 3. Whether you're trying to find the x-intercept in quadratic problems through the quadratic formula, through the discriminant, through completing the square, through factoring, or through using the calculator, either the Advantage way I just previously showed you, or through the normal TI-84 Plus way, your answers always are the same. Thank you for watching and listening to me today, and thank you to Miss Newborn for assigning us this project. Go Lions!